Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. Today we are diving into one of the key patterns for managing data consistency in distributed systems, the Saga design pattern in microservices. If you are preparing for microservices interview, then this question is most repeated question which will be asked. Before we jump into the technical details, let me give you a quick overview of what we'll be covering in this session. We'll begin by understanding how simple asset transactions work in monolithic applications. This will give us a baseline to compare against distributed systems. Then we'll define what the Saga design pattern is, explaining how it works and why it's important in the context of microservices. Next, we'll discuss the challenges developers faced before Saga, especially when trying to manage data consistency across multiple services. And finally, we'll see how the Saga pattern addresses those challenges by breaking down large transactions into smaller, manageable steps while ensuring eventual consistency. This will give you a clear picture of why Saga is such a powerful pattern in modern microservices architecture. Let's get started with the first topic, asset transactions in monoliths. Before we understand the Saga design pattern, first let's understand it with a simple monolithic e-commerce application architecture. Here, all the business functionalities like order processing, payment, inventory, shipping, and so on are bundled together into one single application. All the client devices, whether it's a web app, mobile app, or even a browser, they send HTTP requests to this centralized monolithic application. Now this application processes the request, runs all the related operations internally, and finally talks to just one centralized database at the bottom. Let's walk through a typical flow. Say a customer places an order. Now inside the monolithic application, here's what happens step by step. First, the order is created. Then the payment is processed. After that, the inventory is updated, and finally shipping is arranged. Since all these modules are part of the same application and they use the same centralized database, all these operations are wrapped nicely inside a single asset transaction. That means either everything succeeds or everything rolls back, keeping data consistent automatically. Now imagine something goes wrong in the middle of the process, like the payment goes through successfully, but when we try to update the inventory, it fails. Now the question is, does it make changes in the database or not? The answer is no, because the entire flow is part of a single atomic transaction. And what does that mean? Atomic means either everything happens or nothing happens. There's no in between. So when that inventory update fails, the system automatically rolls back everything. That means the order is not saved, the payment is not captured, no changes in inventory, and no shipping is arranged. Your database stays clean, like nothing ever happened. That's the magic of asset transactions, especially the atomicity part. Everything is handled together as one solid block, so your data always remains safe and consistent.